Hello everyone, and in this video we are going to see about special permissions. So you must have heard this term earlier when we were discussing about the permissions. So in this particular video we'll explore the special permissions in Linux, that is SUID, SGID and the sticky bits. These permissions go beyond the usual read and write and execute and are very crucial for managing shared environments and elevated privileges. So without any delay, let's begin with the practicals of these special permissions. So first of all, let me open the terminal, and over here, what we are going to do, we know about the read, write and execute permissions, that is RWNX. But the topic that we are covering is known as SGID and SUID. So let's talk about it. So we have SUID, which stands for Set User ID, SGID, which stands for Set Group ID, and the third one is Sticky Bits. So we will be covering the concepts of these three special permissions in Linux operating system. So let's talk about SUID first. SUID only applies to files. Okay, the SUID permission only applies to files. And what happens is, when a file with SUID is executed, it runs with the privileges of the file owner, not the user who runs it. So this is the objective of SUID. Means whosoever is the owner of the file, on the behalf of that user, you will be running that command as a normal user if you have the execute permission. Let's take an example here. On our machine, we have a file which is etc not this one. We have a file that is /usr/bin/passwd. If you put ls-l in front of this particular file or this particular executable command, you will see an S here. This S in the owner's side is telling you about SUID. And how we can set it is using this command. We can use chmod, then we can specify plus S, and you can specify something like that, like U plus S, and then you can specify the file where you want to specify the permission. So we have the, let's say, wordlist.txt. If I hit enter and show you the wordlist.txt, you will find that it has a S. Now this one is capital because we do not have executable permission for the owner. If I provide executable permission for all the users, something like this with plus X, then you will find that it is now a small s. So capital S is telling you that this file has SUID bit, but this file doesn't have the executable permission for the other users. So that is why we got the capital S. But when I provided the executable permission, then we got the small x. Okay, so let's continue. So how we can set this permission is you can use these characters like U plus S to set the SUID bit, or if you want, you can use numbers also. So for that, you have to use something like this. Let's say let's choose a different file here. We have a lot of files. Let's choose hashes1.txt. So if I copy it and then use the chmod command with numbers, so the number which is provided to SUID, is 4, followed by same permissions like 777 for providing read, write, execute permission to all the users. Then we can specify the file name. So in this situation, if you put ls-l over the hashes1.txt, you will find that it has the SUID bit set because of this 4. So the SUID is given a number as 4. So that is what you can specify with the SUID. Now let's talk about SGID. So SGID, before that we run a command over here that was this one. So let's understand what's happening here. So the passwd command is owned by root, but needs to update the etc shadow, which only root can modify. So SUID allows a normal user to run it with root permissions to change their password. So that is the objective of the SUID. So normal users can run this command to change their password because of this SUID bit. Moving ahead, let's talk about the concepts of SGID, that is also known as set group ID. So on files, it can do something that is, it can execute, like if the files are executed with good permissions of the file, not the user's group. So if you execute a file, it will be executed with the group permission. But if you talk about directories, then new files inherit the group ownership of the directory. So that is the objective of the SGID. So it works on both files and directories. So this is for both files and directories. So for files, it executes a file with the group's permission, and for directories, it inherits the group ownership to the files or directories which will be created under it. So let's understand with an example. So if you want to set the SGID, let's create a directory here with the permission as mkdir, and let's name the directory as shared. Okay, let's move to a different directory and then do it. Let's move to slash, and over here, let's run the mkdir command followed by any directory name like shared. Now let's understand how we can provide the permission to it. So we can provide permission using 2. So the number which is assigned to SGID is 2. So you can use the numbers which is 2 followed by any permission like 775, and then you can specify the name of the directory. So if you put ls-l with this shared, you will, okay, you have to put it like this. So you will find there is a shared name directory over here which has the SGID set. So this is how you will find the SGID. If you are getting an S here, it means SUID. If you are getting an S here, it means SGID. So now it is set. What we can do is we can move inside the directory, and let's try to change the group of it. So we can use the chgrp command, and we have group 101. Let's provide this group to shared directory. So what is going to happen now, if I ls-l now, you can see that there is a group which is assigned to this particular directory. Now, if we create any directory inside it, so what will happen, that will have the ownership of group 1. So let's move inside shared, and if I create any file like touch file.txt ls-l, you will find that it has the group ownership of group 101. So that is the objective of having the SGID. Okay. So how we set, I told you with one method. If you want to change it with another method, so let's move out, or let's inside this only, let's create another directory with the name as mkdir, the name as dir, and let's change the SGID bit using the chmod command with alphabet this time. So you can use G plus S followed by the name of the directory, which is dir. If you ls-l here, you will find that again this dir has the SGID bit set. SGID bit set, yes. So you can use either this method or you can use the above method of specifying with numbers. So this 2 number is representing the SGID. So that is the concept of SGID. So I hope that it is clear. Now let's move to the final one, which is sticky bits. So sticky bits applies to only directories. So what happens here is users can only delete their own files even if the directory is world writable. So the users who create their file, who own the file, will only be able to delete the file even if the file is world writable. So that is what we can do. So let's take an example here. We can go to the temp directory, and if you want to see the temp directory's permission, you can use -l -lt basically /tmp. You can see that the temp directory has a T set. So this T is representing the sticky bit. It is set. So why it matters? Because sticky bits can without sticky bits, anyone could delete anyone's file in the temp directory. Okay. So what will happen now? Whatever files we create inside it. Okay. So we can we can do an example here. Let's move to the slash directory only. Let's create a directory with the name as let's say Let's name it as demo. And how can we set the permission is we can use chmod, then we can specify uh, like O plus T, O is for others, and then we can specify the directory name, which is demo. So if I hit ls-l here, you will find a directory with the name as demo, and it has T set, which means it has the this sticky bits set. So what will happen now is let's try to let's try to move inside the directory, and let's try to see the permissions of it. So if you try to create something inside this file with any user, those users will be able to manage their own files, will be able to delete their own files, but other users cannot do it except root can do anything, but the other users, normal users, cannot delete the files of any other user. So as a summary, SUID. So as a summary, SUID, the symbol is S on the user, and it runs the file with the owner permission. Then SUID, it represents with the symbol of S in the group, and it inherit the group permission. And sticky bits, it represents with T on others, and it restrict the file deletion. So now you know how SUID, SCID, and sticky bits work in Linux. These special permissions are very powerful tools for user access control and should be used wisely. So try them out and in your lab and observe how they behave. So that is all for this video.
If you want to join the live practical focus training on Kali Linux, then you can contact us on the number shown on the screen.